And last day we finished 4A part 1, and today I'll do 4A part 2. And in this, what you have to show here is area of triangle OBC plus area of triangle OAD is equal to half area of parallelogram ABCD. So let us identify which triangles we are given here. First, area of triangle OBC. OBC is this triangle here, plus area of triangle OAD. So this is the triangle here. If you remember in the last problem we showed that area of this triangle plus area of this triangle was equal to half of the parallelogram. And in this part of the sum, now we need to show that area of these two triangles, the one that I marked in cross, the sum of the areas of these two triangles is equal to half of the parallelogram. And if you remember, I had drawn a line parallel to AB and BC last time, right? For part 1. Now, since these two triangles are concerned, we are concerned with these two triangles now. What we'll do is we'll draw a line parallel to AD and BC. We'll draw a dotted line through O parallel to AD and BC and call these 2 points P and Q. So our construction is draw PQ parallel to AD, parallel to BC through O, so that we get two parallelograms once again. What are the parallelograms? We get APQD and PBCQ are parallelograms. Okay, so I have divided, with the help of dotted line, I have divided the entire parallelogram into two parallelograms. Okay, now comes our observation. What you see is that in this parallelogram, that is APQD, in this parallelogram, this triangle here, that is AOD or OAD, whatever you call it, this triangle here lies on this base AD and between these two parallel lines, this parallel line and this parallel line. So therefore, area of this triangle here must be half of area of the parallelogram APQD. So we write it, area of triangle OAD is equal to half area of parallelogram APQD. And you'll give your reason. Triangle OAD and parallelogram APQD lie on the same base. AD and between AD parallel to PQ. So the triangle and the parallelogram lie on the same base and between the same parallel lines. Hence, area of triangle OAD is half area of this parallelogram. Now we look at the other parallelogram. Now we look at this parallelogram here. which is PBCQ. Now we look at this parallelogram. Okay, in this parallelogram, if you see this triangle here is on the base BC and between the parallel lines BC and PQ. So therefore, area of this triangle must be half of parallelogram PBCQ. Okay, for the same reason. We will write area of triangle OBC let's call this 1 is equal to half area of parallelogram PBCQ. Parallelogram PBCQ. This is number 2. And your reason is triangle OBC and parallelogram PBCQ lie on the same base. This time the base is this one, BC, and between what parallel lines? It lies between BC and PQ. So BC parallel to PQ. Okay. So now from these two relations, what we do is we add the two relations because you have, if you see, you
Good
have,
morning, sir.
good morning. On the left hand side, you have the sum of the area of these two triangles, OBC and OAD. So you have OAD here and you have OBC here. So that is why you add 1 and 2. So from 1 and 2, adding 1 and 2, we get area of triangle OAD plus area of triangle OBC is equal to half area of parallelogram APQD plus half area of parallelogram PBCQ. Okay, so now this is from the right hand side, you can take half common, area of parallelogram APQD plus area of parallelogram PBCQ. Now clearly, if you see in the figure, we had divided the parallelogram into two parallelograms with the help of this dotted line here, PQ, into this parallelogram here, APQD, this parallelogram, and this parallelogram. Therefore, if I add the area of these two parallelograms here, APQD and PBCQ, I will get area of parallelogram ABCD. And that is what we are required to prove here. And this completes our proof. So if you see, area of OAD plus OBC is equal to half area of parallelogram ABCD. And that is what we had to prove. Area of OBC plus area of OAD is equal to half area of parallelogram ABCD. That is what we had to prove. So exactly similarly as we had done in part 1. In part 1, we had drawn a straight line through O, but parallel to AB and DC. Out here, we are drawing straight line parallel to BC and AD through O. Okay, because two different triangles were concerned here. So that is what you need to observe in these kind of problems. The next problem that we are going to do here is 6A. Let's draw the figure for 6a. As I said, as I'm drawing the figure, keep an eye on the proof and keep an eye on what you need to prove and keep an eye on the figure. Try to identify what triangles and which parallelogram they are talking about in the proof. So 6a, the figure looks something like this. This is what the figure looks like. ABCD is a parallelogram. Now let's read the question. In the figure given below, ABCD is a parallelogram. P and Q are 2 points on the side AB and BC. In fact, P and Q are any 2 points on the sides AB and BC of the parallelogram. Any 2 points. You need to prove that. Let's write it down what we need to prove. Area of triangle CPD is equal to area of triangle AQD. Now, if you see in the figure, you can see two triangles CPD. This triangle you can see. This is your triangle CPD and AQD. This is the triangle that you can see. Okay. You need to prove that the area of these two triangles are equal. Now, this is something that is very easy because if you see area of triangle CPD, this triangle here is half area of the parallelogram. Why? Because it lies on this base CD and lies between these two parallel lines. So therefore, area of triangle CPD is half area of the parallelogram. So we write that down. So we have area of triangle CPD is equal to half area of parallelogram ABCD. Call this 1. Also, what you observe is that AQD, if you consider this triangle, AQD, if you are considering this triangle, you also see that area of this triangle must be half of the parallelogram. Why? Because this triangle lies on the base AD of the parallelogram and between these two parallel lines, AD and BC. So therefore, area of AQD must also be half of the area of the parallelogram. Okay, so let's give the reason for the first one. Triangle CPD and parallelogram ABCD lie on the same base BC and between two parallel lines DC and AB. So DC parallel to AB. Now we do the same thing for AQD. So also area of triangle AQD is equal to half area of parallelogram ABCD. for the same reason, but you need to mention the base and the parallel lines. So we say triangle AQD and parallelogram ABCD lie on the same base. What is the base this time? Base is AD. And between what parallel lines? AD and BC. So AD parallel to BC. Okay, call this number 2. Now if you see, area of triangle CPD is also equal to half area of parallelogram, and area of triangle AQD is also equal to half of parallelogram ABCD. Therefore, both the area of the triangle must be equal. Hence, from 1 and 2, area of triangle CPD is equal to area of triangle AQD. And that is what we are required to prove. So we write proved. That's it. Okay, so this finishes this sum. So the easy sum this time. You have to identify the triangles and the parallelogram and what bases they were on. We'll now do number 6b. Fine. This is the figure given. Uh, let's read the problem now. In the figure given below, PQRS and ABRS are parallelograms. You can see the parallelograms. This is a parallelogram. PQRS is one parallelogram, and ABRS. This is another parallelogram. Okay, the two parallelograms you can see, and X is any point on the side BR. So X here is any point on this side BR of the parallelogram. Okay, of the parallelogram ABRS actually. BR is a side on the parallelogram ABRS. Okay, you need to show, let's write, to prove area of triangle AXS is equal to half area of parallelogram PQRS. This is what you need to show. Okay, so let's identify the triangle, the parallelogram, bases, and the parallel lines. Now let's mark the parallel line. These two lines are definitely parallel because PQRS is a parallelogram, also ABRS is a parallelogram, and these two are parallel. Okay, also these two are parallel. because ABRS is a parallelogram. Okay, let us consider now these two parallelograms, that is PQRS and ABRS. If you see, both the parallelograms are on the same base SR, and between these two parallel lines PB parallel to SR. Therefore, the area of these two parallelograms must be equal, because we know that parallelograms on the same base and between the same parallel lines have equal area. So we'll write, we have area of parallelogram PQRS is equal to area of parallelogram ABRS, and we'll give our reason. Reason is parallelograms PQRS and ABRS lie on the same base SR, and between SR parallel to PB. That is, they lie on the same base and between the same parallel lines. Therefore, they must be equal in area. Okay, call this number 1. Now, what you also see here is, if you consider this triangle here, AXS. If you consider this triangle, what you see very clearly here is that triangle AXS lies on the base AS and between these two parallel lines. Of what parallelogram? It shares the base, that this triangle AXS
ABRS.
shares the base with ABRS, and it lies between these two parallel lines.
ABS.
Therefore, again, area of AXS must be equal to half of ABRS. So we write that. So also, area of triangle AXS is equal to half area of parallelogram ABRS. You'll give your reason. Triangle AXS and parallelogram ABRS lie on the same base which one is the base? AS, and between which two parallel lines? They lie between AS parallel to RB. Okay, so now we have shown that area of triangle AXS is half of this parallelogram. But from one, what do we know? We know that area of ABRS must be equal to area of parallelogram PQRS. That means in the next step, I can replace area of parallelogram ABRS by area of triangle PQRS. This is from one. And which is the required proof? Hence, area of triangle AXS is equal to half area of parallelogram PQRS. And that is what we needed to prove. So this is proved. Fine. That's it. I'll stop here for today.